So we're now at difficulty 25.
77.
Okay. So because this is sum, I'm guessing that there's no prime relationship thing going on here.
Between the sum and if it's prime or not.
Yeah.
Yeah. Over 5,000 different ways.
Well, maybe there's something about the prime. So,
yeah, if could be there is a recursion, for example, between if 10 is written like
that's true. Yes, there's
5 times 11. Could it be?
Yeah, it's like a graph thing, I think.
I guess 11 would be less. Yeah.
Well, but so 5 breaks down into 3 and 2, I'm guessing.
Yeah.
And I don't know. Yeah. Well. So. Yeah. So they don't want the actual list. They want the number of ways.
Yeah.
So if we memoize and do recursive stuff, I think he should be able to get something.
Yes.
Okay, let's try recursive def. What is it? Oops. Let's call it Euler 77.
Yes.
I guess n is the number of ways, and I guess we'll do 5,000.
But for the recursive way, we only like counting, for example, only for primes. For example, if for example we say 10 is not prime, but we have its representation, it wouldn't be in this like memoize recursion. You know what I mean?
No.
For example, here we said 5, it's 3 and 2.
Yeah.
But
it would just return 2.
But this is only recursion works for the prime numbers. I mean, for example.
Well, it would only be requested for the prime numbers. Right. Okay. Well. Okay. Yes. You're saying because.
Yes, at least we are memoizing the different ways of if it's prime number. Yeah.
Well, no, look at this. So for example here, I think you have to pass the max prime, the maximum number that thing can be composed of. So for example here you have 8 is the rest. So if I just pass in 2, how many ways can 2 be composed? No, I would pass in, okay, I would be, in the iteration I would be at 2, and I would pass in how many ways can 8 be composed. And I think the way this is structured sort of indicates that I should always pass in the maximum prime. So it should say, it's more like how many ways can 8 be composed using primes up until including 2, or I guess up until 3. I don't know, let's do up until including 2. Likewise, how many ways can 7 be composed up until including 3, and so forth. Okay, so I guess the argument is max p. Okay. Also, we need primes, I guess. I don't know. I guess I should name the thing, but probably it's in 50% of the things. So it's not here.
The brute force would be like starting from the whole any number, like, because
the brute force, yeah, the brute force would be just going through everything.
yeah, like going for each number. Let's say, like, to optimize, we start from bigger number, because we would say at least 5,000 or even more, and then take the just the number of looping through the primes that are less than that number. For example, let's say we start from 5,000 and we're going up. So we take the first prime number that is less than 5,000, and then we take, if there is possibility to, for example, yes, we will pass it to, I think. No, that wouldn't work.
Well, okay, so the max number is certainly the the prime directly below 5,000. So that's certainly true. So I guess the way this works is 5,000 is the rest, or I guess n, and max p would be, well, I guess we need primes. Oops. Well, let's see. We want let's do subprimes p for p in primes if p less than n. And let's just not bother with this separate function, just do it up here. Count compositions, and max p is simply primes minus 1, I guess. That's a prime? Okay, if you say so. Okay, so we go for p in reversed primes if p greater max p. Continue, or I guess also equal to, no? No. It has to be greater. Because the first iteration is looking at 499, which has to be part of it. Okay, so this is kind of a special case. 499, 5000 minus 499 is 1, which is not a prime, so it can't be further decomposed. So I guess, okay, so sub rest equals rest minus p if sub rest 1 continue.
Maybe we can just do if we do that sub rest in primes.
Yeah. Okay, so let's just do, you mean like this. Well, I guess we return 0, right? Okay, so I guess we're doing counts. And here we're doing counts plus equals count compositions rest. And so what do we want here? We want, oh, that's not rest, it's subrest. It's subrest, and as the max p, we're giving, we're not giving p, are we?
And then the next prime.
Yeah. Then
we loop through index.
Okay. Okay. For I in range, then
maybe you can do enumerate and do primes e plus 1. For p in reversed primes we do for for EP in enumerate reversed primes, and then we do composition E plus.
Okay, sure.
Maybe you can put the reversed primes in a list.
In what?
In a separate list, because we're gonna use it again.
Yeah. Well, this isn't a list. Okay. Okay, whatever. Let's just so the next one is our primes I plus 1.
And for the list we do list reversed minus 1. Take. I mean, for the not have the index out of range.
Yeah, I'm thinking, how would you want to do this? I think I'm thinking that maybe this is the better way after all. If p equals if subrest, right? If subrest is less than this, then that's the case where our primes is empty. No, that's let's just think about the other one. So we're looking at 2. Maybe it is p. If we look at the example, then 2 is indeed the max p. I think it is p. Yeah, it is. Right, we're skipping But then we have to do equals. No, it's okay. We're not doing it. Well, I think this is fine. Also, it may be better. Yeah, we'll deal with that in a moment. So, I guess return counts. Okay, but so far we're not incrementing anywhere because all of this always returns 0. So I think every time we generate a rest, we can increment, right? Let's see. No, actually, we have to look at the tail side of things. So if rest equals
8 first.
Let's look at the case where the rest is 5. So if rest, could it be if rest is not a prime, then we return 1. If rest is a prime, yeah, I think that's how we do it. Primes set. So if rest in primes set turn 1. Okay. No? This is dealing with the terminal case. And I think that's the only one that there is. Yeah, I think this is it. So let's just start with, I guess 10 is the example. No?
Okay. Yeah, but you mean, for example, how we can set up the n?
What's the question?
Here, previously, to answer the question, what is the value of n to be set? Is it?
Well, in this example, it's 10.
Yes.
Is that the question?
Yeah. And to answer the question.
To answer, it's 5,000.
No, I think 10 is here is the sum of them, and the number of different way are 5.
You are correct. You are of course correct. Okay.
Yeah, the number of n should be much bigger than 5,000.
Yeah. 5,000 different ways.
Yeah.
Well, so I guess we well, if we do this as a memoized thing, then I guess we can just continue counting compositions.
Yes.
And it should be fairly efficient until we get a number greater 5,000. Okay, so let's just see. We have 4. So already we're off to a bad start, but I guess. Let's see. Print rest max pay. So 10 and 7, 7, 5, 5. Okay, what is the thing here? Print p sub rest. No, that's true. Yeah, okay, rest. Let's see.
Oh, we do reverse? Okay, starting from 7.
I think we're missing the 5 case. Okay, so we're not doing the 5 multiple times. So we should be going right. Wait, 5 isn't a prime. Wait a minute, 5 isn't is a prime. Oh fuck. Okay, yeah. Okay, so I guess okay, so this is not the solution. Because we're dealing with sums and it's not, it has to be composed. Okay, so then we have to iterate through and somehow increment here. Pardon?
Can you just go back with that condition? You are setting it when, for example, for 7, 5, 3, 2. Yeah, and the last death. Okay. So we are incrementing for 7, 5, 3, and the last 2.
Yeah. So here it should be going down all the way to, yeah, it should be going further down in any case. I don't know, is it,
yeah.
I think it's just if subrest greater 1, if subrest return, no, counts else.
But I'm not convinced why it returned only the rest is 2.
This can't be right either, can it?
Yeah, just like let's say we don't care about the 5 case. Is it the 2 case correct?
Yeah, I don't think so.
Yeah, we are like decrementing the rest by 2 always.
Yeah, I think the count has to come from down here, from the bottom, and it has to be a 1. So I guess we just do 1 here. No, yeah, I think we do 1 if we are at the bottom, and we're at the bottom. I guess if it's 2. I guess if it's 2, and that should be okay, but strictly speaking, you can do an optimization because you know the result for 3.
Yeah, but for example, for 3 case, if it's
Oh no, it's not strictly speaking.
I think it's good. Looking a little bit correct. Yeah, if the rest is prime, so it means it can be decomposed to prime.
I think I have a bug. What happened here? So we're somewhere way down the stack trace. Am I not decrementing something? So P is, there's not a 0 in P in primes, is there?
No, shouldn't be.
So we are always decrementing. I guess I can do an assert sub rest rest. But this should always be the case. I guess I can do.
Or maybe it's going negative as this.
Oh, well, even okay. Well, it could be equal to, I guess. Well, wouldn't you know it? Okay, so let's see. Oh. Okay, I guess we say something like this. Let's do this, and maybe this. Okay, so starting at 10, we get the rest 3, we get a count for 3. Starting at 5, we go down to 2, we counted 2, we go down to 3, we counted 3. That doesn't sound right. Okay. We should be going down to 5. Okay, we're going down to 5. And we're looking at the prime 5. And that should be a 1. Okay. I guess if rest max p. No. So we're looking at 5. So the first prime it will look at is 5. And it will get 0. So no rest. I guess we can say if sub rest is 0, return counts. No, that's not right. Right, that this is the same as this case, isn't it? So it's, I guess this is not composable, and this one implies that the previous case was a prime, and it just should continue. But we shouldn't, no, this is wrong. This is wrong. Okay, I think I know. If max, if rest, I think it's maybe if it's just if rest equals max p, then we count this one case in addition to start with. Else it's only the composed things. And we should never but we should only recurse if subrest is greater than 0, right? Which is the same as saying we shouldn't, I mean there's nothing to subdivide if subrest is. Okay, so if rest p, continue. Okay, let's see. So we're going down to 5 and 1. Let's look at this. So for 5, we're getting 3 as a count. Just pull.
Count 2 and 3. So it's right.
Well, it's counting 2 and 3, but it's counting extra, so...
No, because we already have the 7, 1, and for 5 there is 2 cases, so it's correct.
Well, okay, but... Okay, then I guess this is the way.
No, it's only 2.
Well, the result should be 5, right? You know?
Yes.
So somewhere these things are coming from, and I'm not.
Yes,
I guess
but,
I'm counting
up to 5. I think it's yeah, the result is correct, but not sure about what.
Yeah, the output is I guess. So for we're talking about the rest. So for rest 5. Counting once for the 5 itself, and we're counting again for the 2 and again for the 3. Okay, so this is wrong. So I guess this is if this is wrong. Okay, this is also wrong. Let's see.
I think if something would be if res in primes, we do another composition of that. In the yeah. We are doing for 2 and 3. Yeah, maybe for 2 and 3 we...
Let's see. So for the 5, we're looking at the larger primes first. So for the prime itself, we're counting once, and then we should be, the next thing should the next thing should be 3 and not 2. But this is the... So if we count for the 5 itself, when the rest is 5, and we count there, that's okay. If we count for the 2, that's also okay. But... this is counting for the wrong 2. Right? So here, this is generated by having 3 as the prime. And this is generated by having 2 as the prime. So we should be doing, we should be counting here. Actually no. Yeah, we should be counting here with rest equals to 2 and not here. Because 3 is greater than the max p, probably. I'm going to guess. The max p should be 2 in this case, I think. So yeah, so the max p is 3. And here the max p is 2. So there's no way to decompose 3 using only the prime 2. So this is why this is wrong. So let's see. I think this is if sub rest greater p, also continue.
Greater or equal for the 5. Oh, yeah.
So this is correct, right? We're entering at the top level with 5, and we're counting twice. Okay, but what about... Okay, so this isn't correct. This is...
Oh, yeah. For example, if we want to have the 3 and then decompose the 7.
Yeah. So what we actually want is... Well, we're going to go down all the way.
I think
we're going to go down all the way, and this is wrong. And so this is the one case, and I think this is the other case, right? This is where the rest is... I think this might be okay.
I'm not sure if it's that always the stopping condition would be the p minus rest equal to 1 or 2. Could be that our number is the first prime number that is less than our number is the difference between them are more than 1 or 2. For example, let's take as example 500 and not 500, for example 100. 100, the first prime number is like 93, and it's 7. The difference between the rest is 7.
Okay, what's the point?
And then there is no stop condition, or we are gonna do?
I think so. It just, well, the rest would be 7. And I mean, we would further decompose that.
Yeah.
And at some point he gets to, well, he gets to, I mean, we can try it in a moment. What am I doing? Okay, well, we're starting from the larger primes. Yeah, we're starting from the larger primes, and of course the larger, yeah, okay. No, this isn't right. No, it is right. But can I even break here? We're starting from the larger prime, so smaller are to come, so we don't break here. Let's see. Right, we go down all the way to 1 and we don't count for 1. So for 3, we count 0. If rest equals max p, well, max p is 7, so that is wrong. So I guess this is if rest in prime set. I guess this is, I don't know. This is kind of guessing almost. I don't know. This doesn't sound, this is somewhat fiddly. I'm going to go make a tea, and maybe there's a different approach that will produce it easier. Is this related to primes?
You mean the sum is related to prime?
Yeah. Yeah, because it's about, it's not necessarily because it's sum, but because of the composition.
Mm-hmm. Yeah, composition should be primes.
Yeah, because it's composed of primes,
Mm-hmm.
you question is this the same as factorization in some way? Or at least partially?
I don't think it's the same approach. I think we should move if res in prime set.
I think there are two cases. With using mod.
Mm-hmm.
So if rest mod 2 is 0, then we count once. If rest mod 3 equals 0, we count also once. But this is just because there's some row of 3s.
Mm-hmm.
Or row of 2s. So this is 10, right? This is so 10 mod 3 is not equal to 0. So we subtract 3 and we get to 7. We still don't have mod 3 equals 0. We subtract again. And eventually we get to something that is mod 2. No, maybe not.
I think if res in prime set we changed after the sub rest equal here. We just do this here.
Okay. for subrest. And what then?
Counts +1.
You sure? Yeah.
This like to replace that maybe only equal 1, not +1. But it will reset the count.
Before this was... Well, this is the same thing actually, isn't it? So yeah. You just want here 0 then?
Yeah, the loop inside the recursion makes me confused.
Yeah, that's true. But we do need it.
In which case, for here we need it. Let's say, for example, for the 3 case, we have 3 and the rest is 7.
Yeah.
And then we loop through. We take 2. We are not taking 3 yet first. For example, if we take 7 as the max price,
maybe we don't have to loop. Yeah, maybe we don't have to. We shouldn't loop, maybe. We should probably loop on the outside.
Yeah. For the numbers.
Yeah, and for the recursion, it's well, I don't know.
The idea, if it's prime, like we have the number, if it's the rest is prime, we do +1, and also we should continue to decompose. In other case, if it's prime, so we add +1 and decompose it. If it's not prime, we should also decompose it. We should also call this count compositions, even if the rest is not prime.
Well, we do.
Yeah, in any case we do that, yeah. Oh, but yeah, we are passing P as max. Okay.
No, but I think this this whole approach is maybe a bit confused. So if we just consider one top level loop, all right, no, is this even possible to do this? Is the recursion even an idea that's worth pursuing? Because so choose. So if you look at again, look at 5.
Yeah.
So
if the rest is prime, we counted the 5. Yes.
Well, so if we're looking at 5 as a rest, and max p equals 5, then we count once. If we're looking at 5 and max p equals 3, we also count once. And if we look at max p equals 2, we don't count. Right, so these are 3 cases. I think that may be interesting.
I think maybe the idea is to change the parameter of the function. We don't pass the max p, we just pass a number and we do the composition.
Just pass the number. Well, but if we just pass the number, okay, if we pass the rest is 5, how do you get to the 2? You have to look at 5, the prime 5, the prime 3, and the prime 2, at least, in that case, right?
Yes. Well, we need something to know up to what we should look for prime.
Yeah, exactly. And Krübel. I don't know, maybe it just helps to visualize the whole thing. So how many ways to split this up? Well, how many ways to split this up using certain chunks? Using chunk of this length, chunk of that length, and so forth. So I divide this by this, and then I get a rest. And so I have, like, I can extend this so many times, and then I have to take care of the rest. And the rest only works if, well, if it's greater than 1. If it's greater than 1, we know there's some prime factorization of it.
You mean some decomposition?
Well, no, you're right. Yeah, okay, so there's... No, this isn't worth... Okay, so...
Also the number of chunks that are repeating, we can change it and replace it by other pieces. For example, a bigger number like needs 5 chunks of 5. We can do only 3 chunks and replace the other one with 3 and 2.
Yeah. Well, if L mod P n 0, we count 1. But we also have to count for each I guess we were doing that. maybe the way to do this is from the bottom up.
Mm-hmm.
So you construct, I guess, a set of bricks, kind of, that you can fit into some larger thing. Yeah, let me continue. It has to, I think this approach could be valid after all.
Mm-hmm.
Because just looking at this stuff, it seems to me like the rests do add up. Like if I look at the rest 6 and I know max p is 3, then I know that the result I can just pluck out of the calculation for 6. And max p is just implicitly the prime that is lower than the rest, the next lowest prime, always. So I think the main issue that we're having is the terminating conditions.
Yeah.
But maybe we can think about this more clearly now. So So I'm pretty sure that we can say, okay, so let's get rid of this max p, and I think we can also say if rest in prime set then counts equals 1. I think this is correct, and I think that this is bogus, or if it isn't, it should be handled in here. So let's see. This is okay for now, but I think we will probably have to optimize this when the n gets larger, you know. We're starting at, I don't know, 1,000, even though we're looking at rest. Even though we're looking at rest equals 5, we don't need to go through all the primes above, which are huge. So yeah. Then let's see, subrest, I think this is also okay. And this is bogus. And this is also not interesting. But the question is about the other cases. Okay, so this is the one case. I think this is the other case. At some point we're going to get it to rest equals 2 for all of these, and then we'll count 1, and then it will continue. So I guess And that's the one thing. If rest equals 0, subrest, then we continue, because there's no way to partition. That, I guess, also for 1. So now we're looking at 2. Well, okay, no, that's... So yeah, I think 2 would be handled correctly by this, even though it's one function call more than wouldn't it? Would be. Doesn't matter. Okay, so now we're looking at the non-prime subrests. Well, actually, no, we're looking at all subrests. We're looking at, let's say, yeah, we're looking at here the 5 case. The rest subrest is 5. So yeah, that may already be it. Right. Or not. So I'm returning with 1 for 10. Which is fine. I'm returning with 1 for 5, which is not fine. So let's see. We're counting once for 5. Let's yeah, so we're calling for 5, and we count once for 2. Well, we count once when the rest is 2. Well, we count once when the rest is 5. Then we call with 2 as the rest, presumably with 3 as the prime. Well, it has to be. And then we return once for 2, and we return once for 3, and we see 5 is composed 3 ways, which is wrong. So let's see, if rest is in prime set, so we're counting with the cases 3.
Maybe
yeah,
should go up to the half of primes.
Yeah, so
Because
yeah, I think I see. So we're looking at 5, and we get down to the prime 2. And then, so the subrest always has to be
it's similar like to go on from 7 and have 3, and then going up to 3 and also having 7. So if we just go to the half of primes, we are sure that it's always a match up between the half.
I'm not sure about half. but I think it's safe to say.
Yes. Yeah, right. Because we should go up to 3. Oh. Yeah, actually we should go only to half, because this one is covered from 5 and 5. For example, 3, 3, 2, 2 is
Okay.
for example, this one.
Or I guess let's call it min p.
Oh no, but this case we will not be covered. The sum of 2's. Yeah, I think even without going to the, you see, for example, for the 2's we will not ever reach that. For example, here for the 7 and 3 we can generate 5, 3 and 2, and for the 5 plus 5 this can be generated 3 plus 2 and plus 3 plus 2, because 5 is decomposed to 3 and 2. Can you look here? Yeah. For 7 and 3, the 7 can be composed of 5 and 2, and we already have the 3. For 5 it's like 3 and 2 and 3 and 2, but if we only go up to the half we will not reach this case. I mean, because this one is done here recursively, and this one also. This case is done from this case recursively, and we don't need to go like less of 5. But for this one, we will not. We cannot like from those generate this. And also here it's cannot prevent the double count, because I say like this can be generated from here, but also can be generated from here, because we can do 3 and 2 2's and keep the same 3. You know, this case can be like generated recursively from this. If we like have the 7 and 3 and we do a recursive call of passing the 7 to the function, we can have 3 and like this and this and this from as a sum, and we increment and we have the same 3 as this.
I don't get it.
I mean, like for example, we are looping here.
Yeah.
We do a count as we have this. The rest is 3 and it's in primes.
Yeah.
And then we are also are not. I thought the call is passing this, not this, to the.
It's passing rest. Yeah.
Yeah, it's passing this. It's not correct.
Okay. Okay, so it's not that's not, but we are doing calls that are inappropriate, which is to say we are doing, we're looking at the case with, let's see.
I think if we are starting from reverse, why not passing not the rest, but we pass p to the count composition?
Because I don't think it's necessary. I think if anything, it would be an optimization. I think. But in principle, this should take care of ignoring all the p's that are larger than that. So But yes, you are correct. I have to think about it a moment.
Yeah.
So we're counting once. I think the 5 case is still the crucial thing. So we're looking at rest as 5. And so these are these cases. And we are going down. So I think this is the correct thing to look at.
Yeah.
So we have prime is 3 and rest is 2.
Yeah.
And here we have prime is 2 and rest is 3. I think that's the actual thing. So if the rest is greater than the prime, the rest is greater than the prime.
It's the same as reaching the half, but
Is
will
it?
not. Yeah,
Okay.
but it will not work globally. Just for that case inside the second call of the count.
Okay, then maybe I should look at this tree stuff that I have here. Maybe it is the max P.
Can we, for example, do the brute force and maybe try to optimize, like not doing recursive call?
Well, what would be the brute force other than this? Well, we could do something like
compare sets.
I could do combinations and do a sum over the combinations.
Yeah, but the number of items of this combination.
Yeah. So yeah, you can just look at the length of this thing, right?
Why for max p equal is not counted?
Because it's well, the rule
P
one.
more than max p.
Yeah. I don't know. Oh. Yeah, that's correct. So this is the one it's missing now.
Which one?
Yeah.
Oh.
When rest is equal to 3, it's counting 0. It should be counting at least 1.
If rest equal 3, as we did for 2. But anyway, we are doing if rest in prime.
No,
Or we remove that.
Yeah, because that counts too often.
Yeah, I think 2 and 3 are not composite. Like the end of recursion.
Yeah. But, okay. Well, it has to be. Just subtracted it. Then it is prime. We subtracted a prime from the rest, then it is prime. Whereas this check is redundant. If subrest is 0, then rest was a prime.
Yeah.
How am I doing? Count plus equals. Oh, counts. I don't know. Let's see. No, rest. So now we're counting for rest equals 3.
2 times for rest equal 5.
And we're counting for rest equal 5.
I mean, like we do the same as before, but we add the condition if rest equal 3.
Yeah, but that's not the general case. Okay.
Why it's not the general case? Because if it's 3 or 2, it's not composite. The composition ends. Like for example, for it's composite of 2 2s, so we count for 2 only once. And
Okay, I think let's look at 5. The rest equals 5. Prime is a 5. Yeah, and then we have to subtract. Okay. Let's try it. So like this. So for 5 we're counting once. Let's see, wait.
For 3 we didn't count.
So for 3 we're counting once, for the 7 as the pre, for 5 we're counting once, and now we're counting, yeah, so here we're counting where we shouldn't. Right, so the thing is that rest has to also be equal to 0 after subtracting. Right, because if we're looking at p equals 2, no, we're looking at, yes. Okay, let's just look at the failure case. So we're looking at rest equals 3 and max p equals 2. So not only, so rest has to be a prime and the max p has to be also the same value. So max p, so well, let's see. Here it's okay to count, I believe, because I guess max p is greater. I don't know. But let me just try this other thing. I have a feeling that it's going to work. Well, it did not work. So now we're counting, well, we're counting a bit, we're being too loud about it. This does make sense. Returning? No. I mean, technically it is correct. All of this is correct. But this seems strange. Let me just do, I don't know, hash or something. So if we're doing this, this doesn't make sense. How is this a 1? I have, I said counts, counts was 0. No, it wasn't. Rest, rest, rest. None of this makes sense. I'm counting twice, aren't I? This cannot possibly produce the right result. No. What am I missing? Oops. There's no call in between this. I don't know. Am I? Oh, right. Hehe.
I think the else is.
Okay, well then this is, I guess, the solution. Question would be if that happens multiple times for the same thing. Yeah, so somewhere we return, well, it just comes from somewhere else. Yeah, I think this is okay. Let's see. Huh. It doesn't matter, we just, all we have to do is count the number of Ausrufezeichen, and that should be fine also. 1, 2, 3, 4, 5. Huh. Well, okay. What do you think? I think this is also superfluous.
What is the stopping condition when the loop is over?
What is what?
Stopping condition. The loop is over.
It just iterates through all the primes. So the stopping condition is just that there is no more prime. There are no more primes. Is that the question? So I think no, we need this. Yeah, we need this. Okay. Actually, we should be able to point out. Yeah, we do. We do need this. Okay, let's see. At ft, what is it? LRU cache? I don't know. Let's give him plenty. And let's do this and this. Let's, I don't know, start small. I'm not sure how bad this explodes. Apparently not too bad.
It says exactly.
What is the first value which can be written as the sum of primes over 5,000 different ways?
So it's 177.
I think so. Or not. I misunderstood. I bet this is just completely wrong. So Let's see. I don't know. What about? Oh, this is bullshit. Alright, kleine Brötchen wieder backen. Well, this is I'm guessing it's 71. Okay. Do you feel stupid?
I feel sleepy and stupid and yes.
Yeah. Okay. I don't know, this I was pretty sure when I wrote all of this down that the recursive thing had to work. Because if you just go through the steps yourself in your head, it's pretty clear that a machine can do it. Yeah. You didn't even have to limit this stuff. It's just iterating over them and oh, okay.
Yeah.
Let's look at the forum. $76. So the problem just before this one. Yeah. How do people remember solve the same? I don't know. It's like there has to be either coincidence that he solved 31 recently, that he remembers this, or I don't know. Maybe they're categorized in some way. Yeah, so you could, maybe it's a partitioning problem, maybe categorized by that category.
How would we do partitions here? It's a different number sets.
Yeah. Well, we are doing partitions, aren't we? I think so.
Someone mentioned about partitions.
Pardon?
Someone mentioned something about prime partitions. I found this page about prime partitions. Made the graph in Excel.
This is exactly, yeah, this is the exact thing. So,
Euler transform.
yeah, so this is, what is it? 1, 1, 1, 2, 2, 3. Yeah, this is what I have also. So this is this. So then you just have to, yeah, so further. And this is the list. Like if I do 66, I should get 3344. This is the exact function of this, but it doesn't go apparently that far. I don't know. How it's generating. Ooh, that much? Okay. So
for 2 is 1, for 3 it's 0, 1, it's 1, 0, 1, 1.
Well, that is a good question.
For which
this is for 0 and this is for -1.
Maybe if you press to the list, it will like show side by side.
Oh no, okay.
For 0 it's 1, for 1 it's 0. So 0 is a prime?
Well, 0 is, well, I don't know. This is interesting.
This index out branch. Yeah.
What if I do, just for sake of argument,
maybe primes plus 1 up?
No. What do you want to do?
I was thinking about appending -1 to primes. Yes. -1 plus 1 equal to 0. But 1 is not prime.
Games. But that is interesting. Well, let's look at, maybe you can read it from the definition. Prime partition of a positive, well, it says positive.
Yeah. And n more than 2.
So I don't know what this
Can you go it's the linear encyclopedia.
Their page is slow. Somebody is generating graphs. Okay, well, whatever. So yeah, oh, here they have separate case. If a is 1, no wait, no, this is a of n. It's a sub n. The Euler transform. There are at least 3 types of Euler transforms. Well, okay, then which one's he talking about? Bn. Bn, does that signify then Bn is said to be the Euler transform? Okay, well.
Hypergeometric. New names. Have you an idea worked before with quadratic programming?
No. What is this? What?
Yeah, the first time my friend told me about it. Instead of linear programming, there is quadratic program. It's used for like solving, for example, portfolio optimization.
Okay.
They're using something like quadratic programming.
Well, what's the connection here?
Just like all these
mumbo jumbo.
mumbo jumbo names.
Yeah. Okay. Okay, no.
But it was like very interesting thing. Some guy like won the Nobel Prize for this this portfolio optimization using one of these algorithms.
A Nobel Prize?
Yes. Yeah, Markovits. Nobel Prize of Economics. Not sure if it's like too much related, but you can solve a portfolio optimization using the quadratic.
So is this the stuff where you just have to fudge? I think this is where you just fudge the risk factor, right? At the end of the day, this is just a function with parameters, and he says is maximized for a given level of risk.
Yeah.
Well, mathematics won't tell you how big risk is, you know? So if you make a mistake or you're optimistic about how low the risk is, then all this mathematics does is give you a false sense of security, right? You're using high-level super math and it's telling you I have the perfectly optimized Nobel Prize winning certified computer program, and yeah, but the inputs are input garbage, output garbage. So, and yeah, this is what was with these financial derivatives, right? So
you can look at free criticism maybe. Despite.
Because its model of financial markets is well,
does not match the real world in many ways. The same as you said, like.
Well, maybe it does. I'm not sure, but it's the question of the inputs, right?
Yeah.
How risky is something? It's there's no way that this is an input here. Also, there's the black swan thing. So, because this is like, it may be true that if you invest for 1,000 years, that this function will optimize your returns, but it may be that there is a single event with super low probability. It only happens like once in 1,000 years, one day in 1,000 years, which is super low probability, which says this, but it wipes you out completely.
Yes.
It's like, yeah. It's what we're doing with asteroids also, right? The chance of an asteroid wiping out humanity is super low, once in a few million years. And yeah, we pretend we just don't deal with it because super low probability. But if we don't deal with it eventually,
but
some
once it happens,
yeah. So this is the issue.
No one will write that down.
Ja. Okay, cool. Dann danke fürs Kommen.